Hello everyone, welcome to Healthy Techie. Today I'm here, Arjun Shrestha, to discuss about random forest and how random forest is related to AI engineering and also of course data science, machine learning and all. And today we'll be also implementing random forest as well, and we'll discuss about why we use random forest, why we ignore distant trees and then choose random forest, and then we'll also learn about bias and all that stuff, and we'll also be learning parameters, about parameters, hyperparameters as well. And on top of that, we'll also be implementing random forest with iris dataset as well in Python. So let's start with a chapter, random forest. So in short, what is random forest? Random forest is nothing but assembles of decision trees. Okay, so in decision trees there were a big problem. Okay, there were a big problem. What was the problem? The problem was that there was always low bias and high variance. Okay, so to change or to convert high variance to low variance, we use random forest. So what is bias? When does bias occurs? So bias occurs when there is an error in the model, or there is a difference between true value and the prediction value. So there are two types of bias, low bias and high bias. So what is low bias? Low bias means the model is flexible with the data and it performs really well in the training data set, but it performs really bad to the testing data set. Whereas high bias, model takes it very simple, in a very simple way, so that both training and testing data both have less accuracy. They perform really poor. Whereas variance, when there is a high variance, that means a model trains really well even to the noise data as well, but performs really poor to the testing data. So whereas low variance low variance actually is not that sensitive, because even if the training data fluctuates, testing accuracy remains consistent. That means training and testing data are similar. So to convert to high variance to low variance, we use random forest. So once there is a low variance and low bias, then the accuracy is balanced. So that's our main motive. Okay, now coming back to the random forest, how this algorithm is used, or how is this worked in this random forest, let's begin with that. Okay, so now let me just take a pen. Okay, so let's say for example we have a set of data. This is a data set. Okay, so now we have four decision trees. Okay, so now what happens is that in the first phase, a random forest takes rows, or let's say takes row sample from a set of data, and also takes a column sample, or let's say feature sample. What is that? A feature sample it takes. So decision 1 takes row sample and feature sample from the data, and then it will perform, or it will evaluate the prediction, or it will give the prediction. Okay, so let's say when in the first decision tree the value it got was 1. Okay, so let's say we are doing a classification report. Okay, so 0 means no, 1 means yes for now. Okay, so now similarly, now again decision tree will also be fed with the another row sample and feature sample. Right now in this decision tree 2, there is also a possibility that this first decision tree data might also come to the second decision tree as well. So that means decision tree will be learning the same data in different category, right? So that's good for our model. So similarly, decision tree will also take row sample, feature sample, and decision 4 also will take same. So at the end, let's say decision tree let's say predicts 1, 3 also predicts 1, but decision tree 4 predicts 0. So now what it happens in this kind of scenario? So now in this scenario, it will see the majority. It will do a voting system for the classification. If you see 3 decision tree has 1 and only decision 4 has 0, which means the majority is 1. So that means your final prediction would be yes. Okay, so this is also called bootstrapping. This architecture is also called bootstrapping. So this is how overall the random forest works, and it tries to convert low variance to the high variance to the low variance. Okay, and now this is how it is done. So now let's go ahead and implement random forest to the iris dataset in Python. Okay, so in this Python we'll be using scikit-learn. So in the first place, let's get the datasets. Okay, from scikit-learn datasets, import iris datasets. Okay, or let's say load iris dataset, load iris, and then we'll also have to take metrics as well. So from metrics we get accuracy score, right? Okay, I need to give some point. Okay, so masculine from metrics import. So what we need to import? Accuracy score, also let's say classification report. Okay, or let's say we classification report. Okay, also now let's get the model. Okay, I said the assembles. Do you remember the assembles? So random forest is assemble of decision trees. So that way we take assembles and then import random forest classifier. Okay, now what is left? Now also import pandas as pd, and one thing is left. What would that be? So from scikit-learn dot, what is left? Now we also need, what do we need? Train test speed. Okay, test train speed. Okay, sorry about that. We also need now selection speed. Okay, split sorry about that. Train that speed. Okay, what is that? What would that be? Now split, sorry about that, I forgot to take import train this split. Okay, yeah, so now we all have this is good, we have this now. So now let's go and load the data first. Okay, now let's say data is equals to data dot load. What will load? Will load iris dataset. Okay, iris dataset. Okay, or let's say just remove this and just to data is equal to load iris datasets. So now let's set a target and feature. Set target and feature. Okay, so target and feature. Now what we'll do is that let's say data is equals to data dot data. Okay, and data dot targets, setting features and target. Okay, now what we'll do? Now we will segregate the features. So let's say split the data set. Okay, now the next phase will be splitting the data set. So now that would be x train, right? Of course we know about that, right? X train, x test, y train, and y test, right? So now we'll do x, y, or let's say we need to do first train and test split. Sorry about that, train test split. Okay, now what we need to give? We need to give x, y, and then we need to give test size. Okay, for now we'll keep 20%, which is 0.2, and then we'll put random state. So what random state will do is that every time we run this model, every time the same data will go to the training and the same data will come to the testing. So that is what it does. Okay, so now after splitting the data set, now what we do? We initialize the model, right? Oh, sorry about the spelling. Initialize the model, right? Initialize the model. Sorry about that. Okay, now how do we initialize the model? Let's say, for example, model random forest. Okay, now what we do is that anyone has idea what we do now next? So now what we do is that we just call the random forest classifier. So for now what we'll do is that we'll use the default random classifier, that means without fine tuning, and we also might try by using random forest as well. Okay, so now what we'll do is that now since we have already initialized the model, now it's time to put the training data into the random forest. Okay, now let's do train model. Sorry about that. Train model is equal to model dot ref dot fit, right? Fit. What we give to the this? So we give x train. Sorry about that. So we give x train, and we give, what do we give? Y train, right? So Y train has the target data set, right? So instead of train model, let's say this our model. Okay, now it will do fit, right? So now after it fits the model, now the model has been trained. Now what it will do? It will predict. Now we need to take that model and use for prediction. Now let's use the model for prediction, right? Prediction. Okay. Now what would be the next step? Next step would be that test model. Let's say test model, and then let's take our model. Our model will now predict. What will it predict now? It will predict, now it will predict our which data set? Our x test, right? X test data set against, and then it will also take the, now it will predict this x test with y test, right? It will predict that, or no, right? It will only predict x test. It will predict x test, and then if you want to check what our test model has predicted, we come here and then we give the other data, check. Let's say check accuracy. Okay, we'll check the accuracy now. So when you check the accuracy, what we'll do is that now we'll do accuracy score, or let's do classification report, but because it will give us more precise information. So what we'll do is that we will put the y test, right, and then we'll put it against, compare it with against our model test, test model. Okay, now if we print, what we print? Check accuracy. If we print the check accuracy, let's do this. Let's do the accuracies. Let's just say accuracies as of now. Okay, and then give comma, it should be okay. Okay, now if we save this file and just run python3.test.py, it should give us 1. Okay, it's taking a little time, that's weird, but yeah, we should be good. Okay, so it should actually give 1.0, because since this is a IC data set, so that should be fine. Okay, x is not defined. Okay, it says that x is not defined. So why did we do mistake? X10 x test. Okay, it says x and y. Okay, I think we did one mistake. So not a mistake, but I would say, okay, we did mistake. Okay, now we forgot this one. Okay, this is how we are supposed to set target and feature. So before we did data, but that's not the correct way. But yeah, but we learned with the errors. Okay, so let's clear it again and let's write it. Let's type it. Let's type it now. Hopefully this will work. If not, then we'll have to do it again. But that should be fine. This is a learning phase. Okay. Now let's see. Let's wait for it. It should be fine now. See? Okay. Now the accuracy is 1.0. Why? Because iris data, because it's an iris data set. Okay, if we fetch the other data set, let's say for example financial data set or any other data set from the Kaggle, then the accuracy might be very very low, but that's fine. But let's say for example if we want to fine tune it, well, even if we fine tune this model for this data set, it's going to give 1 no matter what, because since it's a iris data set. But if you want to try, what we can do is that you can just give, for example, let's say max depth. For now, let's just give max depth. Okay, let's give max depth 5, and let's say for example n estimators maybe 200. Okay, but it's not going to change anything. Okay, I'm just doing to show how to fine tune the model. So this is the process of fine tuning a model. Okay, so this is hyperparameters. Okay, hyperparameters are those parameters we use to make some changes in the model so the model can learn well, and the parameters are the one that learns with the model, right? Parameters, when we give parameters like coefficient and all that stuff, now those coefficient will be learning from the data, but these hyperparameters will make some changes in a way that the training model can learn better. Okay, so again let's clear this out again and let's run again. Okay, sorry for that. Python 3 dot test dot py. Okay, now it should still give us 1, but still, it's good to see how much. Yeah, see. So yeah, this is how it works. But yeah, and I'm sorry about some of the mistakes we did. Sorry about that. And yeah, so I hope you guys enjoyed this video, and if you like this video, then please comment it down. Then also I can make more this kind of videos in the future. I can use LSTM, and I can show you guys how LSTM can be implemented and how can we use LSTM as well. And I know these days we can learn a lot from ChatGPT. So of course I will also suggest and recommend you guys to go to ChatGPT and then just try with some prompting and then try to understand how it works. So yeah, for today, thank you so much guys. I hope you really like it, and hopefully we'll see you again. Thank you so much.